Chapter 6, Section 4, Solving Absolute Value Equations and Inequalities. So just a little quick reminder. First, let's think about what absolute value means. So if I were to say the absolute value of x equals 7, that means that x has two solutions, 7 and negative 7. Because when we're talking about absolute value, all that means is the distance from 0. So to solve absolute value equations, you can use the fact that the expression inside the absolute value symbols can be either positive or negative. So if we look at this type of an equation, it says solve the absolute value of x minus 4 equals 8. So this expression, x minus 4, can be equal to 8, or it can be negative 8. So if we said x minus 4 is positive, so that means it's equal to positive 8, we would solve for that. We would say, and then you would just treat it just like a normal equation and solve for x. So we remove our absolute value signs, then we have x minus 4 equals 8, add 4 to both sides, x equals 12. Now, if we said that x minus 4 is negative, that means that the absolute value of x minus 4 equals negative 8. So then again, we solve it like our regular equations. X minus 4 equals negative 8, add 4 to both sides, we get x equals negative 4. Now, to double check this, we would go back and we would put it into its original equation to see if this is true statements. So, according to this, we have two solutions, 12 and negative 4. So if we go back up and we plug in 12 to our original solution, so the absolute value of 12 minus 4 equals 8. Well, 12 minus 4 is 8, so the absolute value of 8 equals 8, which is a true statement. 8 equals 8. Then we come back up here and we plug in negative 4. So negative 4 minus 4, or the absolute value of negative 4 minus 4 equals 8. So negative 4 plus a negative 4 is a negative 8. So the absolute value of negative 8 equals 8, which also is true because our absolute value is the distance from 0. That's 8 units from 0. So 8 equals 8. So let's do one that's a little more complex. If I have something like this, it says solve the absolute value of 5x plus 1 and absolute value plus 3 equals 14. So what we do here is first we isolate the absolute value expression to one side of the equation. So what we need to do is get rid of everything outside of these absolute value signs. So basically get it to the other side of the equation. So in order to do that to this particular equation, I would subtract 3 from both sides. So now I have the equation of the absolute value of 5x plus 1 equals 11. From here, we go up and apply the same rules that we did previously. So we say the absolute value sign can either have a positive or a negative outcome. So if we said the absolute value of 5x plus 1 is positive, we would plug in positive 11. So you can see 5x plus 1 equals 11, subtract 1 from both sides, 5x equals 10, divide by 5, x equals 2. And that's if it's a positive. So now, if it's a negative, we would do the same thing. 5x plus 1 equals negative 11. Subtract 1 from both sides. 5x equals negative 12 divided by 5. So x equals negative 2 and 2/5, or negative 2 and 4/10, 2.4. And then again, just to prove, we would go in and we would plug it into our original equation. Our original is the absolute value of 5x plus 1 and absolute value plus 3 equals 14. So you can go here, see your math. I plug in 2. So I keep my absolute value signs. 5 times 2 plus 1 is all in the absolute value signs. So that's 10 plus 1, and then I have plus 3 equals 14, plus 3 equals 14. You could do this one of two ways. I subtracted out my 3 on both sides, which is fine, and then I get the absolute value of 11 equals 11, or I could do the absolute value of 11, which is 11, plus 3 is 14, and 14 equals 14. I didn't write that part down, but that is another way that you can solve that, or think of it. Either way, they both show true statements. And then on the other side, the absolute value of 5 times negative 2.4 plus 1 and absolute value plus 3 equals 14. Again, I subtracted out the 3 on both sides, but you can also add it in there. So negative 12 plus 1 is negative 11. If you subtract out these, you can see 11 equals 11. Or you can say, what's the absolute value of negative 11? Well, that would be a positive 11 plus 3 would be 14. And 14 equals 14. So again, two different ways. So, again, the reminder about the absolute value. So, absolute value is the distance between x and 0. Here's a visual example for you. If the absolute value of x is less than 7, then any number between negative 7 and 7 is a solution to the inequality, because that's just saying that it's 7 units from 0. So if I look at negative 7 to 0 is 7 units, and positive 7 to 0 is 7 units. So that's how we can get a positive answer and a negative answer, because both of these are 7 units from 0. So it's a little more in-depth explanation. So now let's talk about some rules, and especially when we're talking about inequalities. So here we go. Each absolute value equation or inequality is rewritten as two equations or two inequalities joined by the words and or the word or. So let's give some rules here. So here we go. The absolute value of ax plus b is less than c. So that means ax plus b is less than c and ax plus b is greater than negative c. So the rules still apply with our negatives. So if we're going to do a negative number, then you flip the sign. Same rules. So you just got to remember to flip the sign. That's probably one of the most error type of these problems. So negative sign, if you change to the opposite, you flip your sign. And then if you look at this one, the absolute value of ax plus b is less than or equal to c means the same thing. Ax plus b is less than or equal to c, and ax plus b is greater than or equal to negative c. Again, we flip the signs. Now notice something. These have and. So when the absolute value is less than a number, the inequalities are connected by the word and. Because once you solve them, you'll see that they will connect on your graph, and those types are compound inequalities that are connected with the and. Now let's look at an equal and greater than. So again, we did some examples of this. The absolute value of ax plus b equals c means ax plus b equals c, or ax plus b equals negative c, because when it equals something and they're opposite, it has to be an or in this case. So if we have the absolute value of ax plus b is greater than c, that means ax plus b is greater than c, or ax plus b is less than negative c. Again, flipping that sign. The absolute value of ax plus b is greater than or equal to c means ax plus b is greater than or equal to c, or ax plus b is less than or equal to c. So again, we're going to do some problems here, and you'll see that when we have our greater than signs and our equal signs, they actually, and graph them, they will be or graphs. Now the way I remember it is great or. I kind of changed the saying. Great or, that means it's an or sign. Greater than, see, great or, I don't know, my little cheesy trick. So again, when the absolute value is greater than a number, the inequalities are connected by or. So let's do some examples. So solve. The absolute value of x plus 6 is less than 8. So less than, I know, is going to be connected by an and. So again, I'm going to go through and I'm going to say, okay, if the absolute value of x plus 6 has a positive answer and a negative answer. You do two type of problems. X plus 6 is less than 8. Subtract 6 both sides. X is less than 2. X plus 6 is greater than negative 8 because, again, the negative, I flip my sign. Subtract 6 from both sides, so x is greater than negative 14. If I were to graph these, you would see that they would overlap each other. So it's less than 2, greater than negative 14. And since it's an and, I can write it as a compound inequality of negative 14 is greater than x and less than 2. So you would write it as our compound inequality when we have an and. Let's do a greater one so you can see the or problem. So the absolute value of x minus 9 is greater than or equal to 1. Great or, right? So it's connected by the word or. So again, you have it as a positive and as a negative. So my positive is x minus 9 is greater than or equal to 1. Add 9 to both sides, x is greater than or equal to 10. Here, now it's my negative, so I flip my sign. X minus 9 is less than or equal to negative 1. Add 9 to both sides, x is less than or equal to 8. And again, or signs, because it's greater than 10 and less than 8. All right, and one last example. And I'm going to show you on a graph here. So we're going to combining some of the things. The absolute value of 3x minus 3 and absolute value plus 4 is greater than or equal to 10. And then graph it. So first I'm going to isolate it. I'm going to get rid of my absolute value sign on one side of my inequality. So here it is. I subtract 4 from both sides. The absolute value of 3x minus 3 is greater than or equal to 6. Then I go through and I do my positive and my negative possible solutions. So 3x minus 3 is greater than or equal to 6. Add 3 to both sides. 3x is greater than or equal to 9. Divide by 3. X is greater than or equal to 3. On the other side, when I have my negative, I have 3x minus 3, and I flip my sign as less than or equal to negative 6. Add 3 to both sides. 3x is less than or equal to negative 3. Divide by 3. X is less than or equal to negative 1. So again, it's a great or. So the or is the connection. And if you were to show you, I have x is less than or equal to negative 1, or x is greater than or equal to 3. And I graph it. You can see they don't connect. And that's an or. So that is how we graph compound inequalities using absolute value. So come prepared with questions and we will do some work in class. Have an excellent night.